Hello, welcome to Lecture 1A on Systems of Linear Equations. Reminder to please take the welcome survey, and there is a reading homework associated with this lecture that is due on Tuesday at the end of the day. We begin with the study of linear equations. A linear equation in n variables, x1, x2, x2 through xn, is of the following form. For some numbers, a1, a2 through an, and b. The numbers a1, a2 through an are called the coefficients, and the number b is called the constant term. Here are some examples of linear equations. Here is a linear equation in two variables, x and y. You might remember that this represents a line in two dimensions. Here is a linear equation in three variables, x, y, and z, and another linear equation in three variables, a, b, and c. Later, we will see that these represent planes in three dimensions. One thing to note is that each variable in a linear equation occurs to the first power only. So for example, something like a square plus 3b equals to 1. So this would be an equation, but this is not a linear equation. We are interested in finding or saying something about a solution to a linear equation. A solution to a linear equation is a choice of values for the variables for which the equation holds. For example, consider the linear equation 2x minus 3y equals 7. The pair of values 5 and 2 is not a solution, because if we substitute 5 and 2 into the equation, we get 2 times 5 minus 3 times 2, which is not equal to 7. On the other hand, the pair of values 5 and 1 is a solution, because if we substitute 5 and 1 into the equation for x and y, we do get 2 times 5 minus 3 times 1, which is equal to 7. The pair of values 3.5 and 0 for x and y is also a solution, because if we substitute 3.5 for x and 0 for y, we do get an equality. A single linear equation typically has lots of solutions, and the notation parenthesis x comma y, or like some other expressions. So this notation lets us describe multiple values at once. Here are more examples of solutions to a linear equation. So here we have this linear equation in three variables. The triple of values 5, 1, and 0 is a solution, because if we substitute 5, 1, and 0 for x, y, and z into our linear equation, we get equality. And you can also check that the triple of values 3.5, 5, and 3 also gives a solution. And like I said, a single linear equation typically has lots of solutions. Here, if we have three variables, then you would use this notation to describe multiple values at once. In this class, we are interested in a system of linear equations, sometimes called a linear system. This system is a set of linear equations in the same variables. So here's an example of a system of two linear equations in the two variables x and y. And here is an example of a system of two linear equations in the three variables a, b, and c. A sequence of numbers is called a solution to a system of linear equations if the sequence of numbers is a solution to every equation in the system. So let's take a look at this linear system with two linear equations and two variables, x and y. The pair of values 5 and 1 is a solution because we can check if we substitute 5 and 1 into the first equation, we do get an equality. And if we substitute 5 and 1 into the second equation, we also get an equality. But the pair of values 3.5 and 0 is not a solution because even though if you substitute those values into the second equation, you get an equality. But that is not true if you substitute them into the second equation. In the previous example, we saw a system of linear equations which does have a solution. But it's possible that a system of linear equations does not have any solution. So here's an example of such a system. So how can I tell that this does not have a solution? So one way is to say, okay, suppose there is a solution. So that there is a pair of numbers, a and b, such that it satisfies both the first and second, or such that it is a solution to both the first and second linear equation. So in particular, a and b must be a solution to the first equation. So I have a plus 2 times b is equal to 1. And a and b are just numbers. I can multiply both sides by 2. So I have 2a plus 4b is equal to 2. But now this shows that 2a plus 4b is equal to 2. And it is not possible for 2a plus 4b to both be equal to 2 and also equal to 1. So this is not possible. So this shows that such a pair cannot exist. So a linear system like this with no solution is called inconsistent. And a linear system with solutions is called consistent. So this linear system is consistent because we see that it does have at least one solution. And this system is called inconsistent because it has no solutions. It's also possible for a system of linear equations to have many solutions. So in this exercise, we want to show that the set of pairs 1 minus 2s and s for any values of s is a solution to this linear system. Now, I'd like you to pause the video and try to do this on your own and then come back to the video. Okay, so to show that this set of pairs for any s is a solution of the system, we only need to verify the following. So I will substitute x with 1 minus 2s, and I substitute y with s. So this is the first equation. And indeed, it is equal to 1. And I also verify that if I substitute these values into x and y for the second equation, I also get something consistent. So I have 2 times 1 minus 2s plus 4 times s, which is equal to 2 plus 4s, or 2 minus 4s plus 4s, which is equal to 2. And I am done. This is the end of lecture 1A. Again, reminder to take the welcome survey and also do the reading homework associated to this lecture 1A, which is due at the end of Tuesday.